Today's video is dedicated to solving those lab exam problems. So they might ask you, here's a liquid. You have liquid that is impure because there are two samples in there and you're given the boiling points of them. Or you might be given just a plant, just a herb, and you're asked to extract something. Now, if you see these cues, if you see boiling point of two liquids, and you need to purify it, it's going to be liquid extraction using distillation. And if you see a herb and they tell you just to extract it, it's going to be a solid liquid extraction. Okay, so I will show you the techniques, but first, both of these will require somewhat of a similar setup. So in solid liquid extraction, we start with a reflux setup. We have a round bottom flask, add some boiling stones to it to prevent bumping of liquids, clamp it, okay, and then add a heating mantle that is connected to a variac, never to the power outlet, and put this on a lab jack. Then you would add a condenser, hopefully a waterless condenser, at the top. Make sure it is tightly sealed here. This needs to be tightly sealed. And then that will be our reflux. And then make sure that in the boiling stones you've also added some solvent. So you got your plant and some sort of solvent such as ethanol. Make sure to never boil this to dryness, never boil it to dryness, and never add any stopper at the top. Never heat a closed system. Okay, so this is the setup for the reflux. Now, the distillation is also very similar. I will use the distillation, draw it out in pink. All right, so distillation is very simple, but now you will need to use a water condenser. So instead of a condenser at the top, on top of our flask, instead of this, it's now going to be a still head. Okay, so down here everything is the same. It's now going to be a still head, so you're going to have like a little opening, and here you want to add a little thermometer adapter and put your thermometer just up here and the bulb just where this juncture is. This is our thermometer. And with this still head, you want to connect your water condenser. Okay, so your water condenser, and you want to make sure to use clamps and clips wherever you can. Okay, and then here you'll want to clamp this entire condenser so it doesn't fall off, and you will connect this with a tube as water that is going out. Okay, so this is like an upward water fountain. Water is going in through the bottom and out through the top. All right, so then at the bottom here we got a water condenser, and make sure to have some receiving flask. Okay, so there's usually like a little apparatus that looks like this as well, and your receiving flask could be anything. It could be a tube, and make sure that you turn on the water gently. We want 1 drop per second ish. All right, so that is a setup for distillation and reflux. But now the procedure for this, let's start with a solid liquid extraction procedure. So what you're gonna get is you're gonna essentially be burning out all your liquid except for 2 millimeters at the bottom. Never boil it to dryness. So once that is done, you're gonna have just a little bit of some solids in there and also a little bit of oily liquids. You're gonna dump that out and put it through gravity filtration. So you got your filter paper in a funnel and this. So gravity filtration, because it's hot liquid, so we use that. Don't use vacuum filtration because hot solvent does not work with vacuum filtration. You use hot gravity. So you're gonna get a little bit of oil at the bottom and a lot of the plant material solids that you burn at the top. So this is going to be your extracted compound, and ideally you want to put this through evaporation, because there might still be some liquids in here. You want it to be totally pure. So this is gravity filtration. So then you want to evaporate it. Evaporate the compound you got to make sure there's no other liquids in there. So you can use reduced pressure evaporation. You put a cork on it and you get a filter flask. So then you will connect it to a tube, which is connected to a larger vacuum trap, and you put a cork on it, as I said, and yeah, and you evaporate it. Essentially what you're gonna get down here, hopefully if you get something, is your your purified product. And with this purified product, you are not able to calculate your percent recovery. So when you're doing solid liquid extraction, you want to do percent recovery, which is the purified bioactive compound that you obtain at the end after evaporation, divided by the initial planned solid material you had, times 100. So that is how you do solid liquid extraction, which starts with reflux, and you just go through gravity filtration and evaporate to further purify your extracted bioactive material. So that's that. But now let's go back to liquid extraction. So by this time we've collected a few fractions of liquids, and what we're going to do now is we have to combine the fractions that gave us our pure compounds. So you will be recording a large table, and you'll find that somewhere in the middle and somewhere near the end, you're going to have a bit of a temperature plateau. So this is where, what's it called? This is where distillation graphs come in. So where you see a little plateau here, okay, it's going to plateau, dip a little bit up, and then plateau. So these two plateaus is where you're going to find your pure compounds. So you take out those fractions and combine them if necessary, and then that's how you get your pure product for distillation. Now I want to note this is fractional distillation, which is good for compounds that are under 25 Celsius in boiling point difference. So you can use fractional for really close boiling points, and you can use simple distillation for two compounds that have greater than 25 Celsius boiling point differences. And one other thing is about liquid extraction. We are doing this based off boiling points. Okay, so that means there's going to be a corrected boiling point that you're going to record on your data table, and the formula for that is such that the corrected boiling point is not actually going to be the boiling point that you see, but it's going to be very close depending on where you live and your observed boiling point. So this is observed boiling point. So now we add in a correction factor, which is calculated by 760 torr minus the atmospheric pressure in torrs divided by 10 torr and times half. This is something you want to memorize for the lab exam as well. So that's all for extractions.